Hello everyone. Now we deal with linear regression. Some people said it's not coming and some people said it's coming in the exam. But so I asked, me and Sadman, we're of the opinion that you should know what it is, just in case it comes. So linear regression is based on a simple concept of correlation. So for example, height and weight, it's a very commonly correlated value. The more somebody's height is, the more their weight will be because bones and muscle and how the body works. So what is correlation? Correlation is simply a relationship between two values. Now in let me just write an example. So let's do like height, and there's like four different heights in there, and weight is like some different weights in there. In MATLAB, if you want to find the correlation between them, you use this method. Core coef, which stands for correlation coefficient, and you will give it, bro, what the hell are you doing? That stuff looks like Java code. Imagine that actually comes in the exam and all of us get cooked. That would be funny. We would all meet in the retake, including Sadman himself. See, when I do correlation coefficient between height and weight, I get this 2 by 2 matrix. Well, 2 by 2 array. Well, no, I think that's a matrix. Okay. So you can see that it has two diagonals. Like it has 1, 0.4, 0.4, 1. The first diagonal is the relationship of each element by with themselves. So of course height to height is the relationship is 1 because it's itself. And the second diagonal is the relationship with each other. So this is the relationship of height with weight, and this is the relationship of weight with height. Since this is a linear relationship, they will always be the same. That's all you have to know about the correlation. Now, what is linear regression? So imagine we have some points on a graph, like points like this, and it's like a graph. Linear regression is we find the best fitting line that passes through all of those points like this. So I have no idea what it means, but that is it's the definition. You're watching, I went through the members list and I didn't, oh, okay, there you are. Okay. Yeah, it's a straight line that goes in between the points. Just, ignore this. Suppose there's like points, and it has to be a straight line. We try to fit it that goes through all the points. So the best fitting straight line that goes through all the points. Okay, that's linear regression. In MATLAB, the function used for that is fitlm, which stands for fit linear model. So for this, I think it's best if I just show you an example. Well, in this case, I have the weights, right? Height and weight. So for now, ignore the correlation coefficient. Well, you know what, I'll delete it because it confuses some people. Fit ln. So for fit ln, first you give height. Well, the first thing that you're fitting, then the second. Then you also have to tell it what kind of relationship it is. It's linear. Remember, all we will be doing for this semester is linear. You don't have to worry about anything else. And then you run. There you go. It does it. So here, the most important thing is to create the equation because he might ask you for the equation of this linear model. So the formula for this equation is just the equation of any line. It's the equation of any line, which is mx plus c. So in this case, forget the other columns. The estimate column is the only one you'll be needing. So this x1 is x, well, it's m, and this is the y-intercept. So if you were to write it, it would be 0. By the way, my data is really bad. So in a real data, this lower one will be more elegant than 0.07. But this, it's this x plus, so in this case, it would be the equation that you write would be 0.0078 x plus 20.542. So now let's look at the actual data set that we have been given here. Hours spent studying compared with the exam result that they got. So we'll just make the vector hours 70, 23, 4, 57, 40, 34, 69. So these are the hours each student spent studying for the exam, and this is the result they got. But if I was the guy that spent 18 hours studying and I got the same result as the guy that spent 0 hours, I would feel bad. Okay, so hours, I'm going to do grade, which is 53244, 35114. Okay, and it's linear because all that is linear, so we fit element. Hours, grade. By the way, in this case, the order matters. I will tell you, depends on what. So first we just do the fit element. You can see here the equation will be 0.054 x plus 1.2065. Now that's the equation part. What is commonly asked in the questions? Well, not commonly asked, but it can be asked. The main use of fit lm is, okay, so you do the fit lm, you store it in a variable, and then you use the predict function. What if the question was if you got a grade of 3, uh, wait, if you got a grade of 3, then you predict how many hours you studied for. It says, how much time should I spend preparing for the test if I want to pass with a 3? So in this case, the order in the fit element, it matters. So you have to write grade and the hours, and the grade is given and the hours is required. So in the fit element, you give the grade first, then you give the what is required later, hours. Now, since that is done, then you use the predict function. So the order method, see in this case, it says how much time should I spend preparing for the test if I want to get a 3. So we are given the grade. So here we have two arrays. The first one is the grade, the second one is the hours. And inside the fit lm function, we have to pass both of them. But which one do we pass first and which one do we pass second? In this case, the grade is given. So we pass grade first. Hours is given second. So we pass the hours second. Let me just confirm that. Yeah, that's what it says here. So grade is given, we put it first, hours not is required, so we put it second. And then we use the predict function. So the predict requires an alpha value and then the given value. Well, not the alpha value, sorry. Not the alpha, the result of the fit element. So we stored it in the fit variable. So then we go predict fit, which is the result of the fit element. And then what is given? So we have the grade given. And we want to predict how many hours it will take. Okay, now we run this. And it says we should study for around 33 hours if you want to get a 3. It's based on this data. Now, let's see what happens if I flip the hours in the grid. Like if somebody messes up the order. It would say 1.3 hours to get a 3. And you already know that's messed up. But yeah, given comes first. Okay, so that's the prediction. Let's try one more. It says if, let's see, if you studied for, let's say, 50 hours, predict your grade. I'll just delete it and it forces us to redo the whole thing. Okay, so we create the fit, we do fit lm. Since the hours are given, we do hours first, then grade second, and of course make it linear. And then predict, we pass in this into the predict, and what is given hours. So 50 hours, let's predict our grade. We will get 3.93. If the confidence interval is given, we can also pass in the alpha to it. We need to put in the alpha in the predict. It can sometimes change the answer. But yeah, that was it for linear regression. Now the only last thing left is ANOVA, which I will do in the next meeting. So give me like 10 to 15 minutes while you practice linear regression. I'll revise ANOVA and then I'll explain it. Any questions about linear regression? 5, 4, 3, 2, 1. Wait, something. Please, can you explain order? Hey, what's the problem with the order? Yeah, everything is in the notes, what I just did. Like you just have to get the fit lm and okay. Well, let me continue. So what do you not understand about it though? Yes, Spencer. When do we know when order matters? See, you are given something. It is if you studied for 50 hours, then predict your grade. So hours is given, right? This array is given. So we pass in the given one first. If the grade is given, we pass in the grade first. If none of them is given, like if the question is just if you have to find the correlation equation between hours and grade, in that case our order does not matter because nothing is given. We just have to find that equation. So then predict also doesn't work. We just have to do the fit lm and we get the equation this way. Like it's in the notes as well. This will be m and this will be c. So y is equal to mx plus c. It will become 0.0546x plus 1.2. Do you get it? All right, good shit, man. All right, then see you in the next one.